Hello. I love these, like, as my new friend from the elevator and I were saying on the 14 stories down, it's so fun to be at a small conference where everyone's in the same room and you aren't all fragmented, and people are running late, so you have a few more minutes to finish your slides. Like, these things are all great. No, I'm super stoked to be here. Thanks for inviting me, Nora. This is a new talk that I've never given before, so I think the content is good, and the slides, I'll give myself a C-, so we'll see how it goes. That's me, Honeycomb. The new colors in our logo. Oh man, I should have brought some of the Honeycomb nail polish. Man, I didn't. Oh man, we just got this nail. So you can see the colors, right? The hexes. I just got this new nail polish made that is hex glitters in all different sizes and those colors and little silver sparkly ones, and it's clear. It's with the topper, and it's really dope. But you can't have any because I didn't bring any. Sorry. Yada yada, books, etc. Bloop bloop bloop. That's because it's new. Still shiny. Debugging. What is debugging? This is not a trick question. I was like, what does Google say about this? Because I went down in a bit of a rabbit hole, and like the dictionary was like, well, it's the process of identifying and removing errors from the blah blah blah, and AWS Docs was like, well, this is the real gospel of the internet. They're going to tell me for real what it is. Computer programmers study the code to determine why any errors occurred. Sometimes they do that. Is it effective? But like all of this is debugging, right? Like, and so much more. But in this talk, I want to focus kind of specifically on not the debug. I feel this might be controversial. Again, I'm not a software engineer, so I feel like I can speak flippantly about other disciplines. I feel like debugging software is pretty easy these days compared to debugging systems. Systems is getting harder, right? Whereas software, like we've got like all these fancy like new IDEs that do all the work for you. So I'm told I still use Vim, but like it's almost like as soon as you know where in the system is the code that you need to debug, your job is like 90% done, right? Like once you figure that out, and observability is how we do that, right? Like we all know this. And I started drawing this like. I started drawing it all out, and then I was just like, well, it's just using there's the wild things, right? Where the wild things are is on the system side. That's where nobody really knows quite what's going on ever at any given point in time. You're never dipping below the weakest bit of the surface, which is why it's fun. Debugging, however, I think is indistinguishable from understanding. You don't even know if it's a bug or not, right? Until you understand it. What I think is kind of unfortunate, and it didn't really occur to me, is that for most engineers, debugging, because they have to solve a problem, is one of the only times that they're motivated to go and understand why how their system works. It's kind of weird, right? Like, I mean, debugging is just a type of understanding, but like, I know that when I understand my system better, like, my work is so much easier, but it's so I kind of feel like debugging is kind of it's like the tip of the ice cube, and many a bright young front-end engineer has gone debugging and found themselves like doing Kubernetes before too long. So I like to think of debugging as like the gateway drug for understanding your software. I would also like to point out that production is the only place that code can be understood, because it's the only place that it's real. I think that the measure of a great engineer is much less about the code that they write and much more about the code that they understand. I mean, you can write good code by accident. I just hit the thing. You can write good code by accident or by skill, but do you even know if the code is good or not? That takes understanding. We actually spend a lot of time trying to understand code as opposed to systems, right? If any engineer starts a new job or comes into a new project or a new team, and you're like, oh, okay, you need to come up to speed on this code, they typically open up GitHub in their editor and start looking through the code. When the way I think about it, it's like, I mean, that's a starting point, but like the source of reality is your instrumentation inside your code telling you what it's actually doing. Anyway. Your facility at learning and understanding this code, though, you might actually, if you're a job for long enough, you might end up having to learn and forget the same piece of code like many times. And I feel like the richness of your mental model and your ability to understand your code really contributes dramatically to your overall effectiveness as an engineer. But if understanding our systems is so powerful, then why don't we do it all the time? And there's a lot of reasons. I think, it used to be really hard. It's still pretty hard. A lot of times, devs are just like, it's not my job. My job is to write the code, and your job is to run the code. Debugging is not actually exactly taught in schools. We tend to learn by banging our heads against things that aren't working, watching each other and making the same mistakes over and over. Software can only be understood in production because when your software is being used, it's real. Otherwise, it may as well not exist, right? This is software that isn't in production is dead code. It's meaningless. It doesn't matter. As soon as somebody's using it, as soon as it's being applied somewhere, then it's interesting. Production tooling has sucked for a long time, so let's take a little bit of a trip down memory lane and understand why. 2003, right? For a long time, we wrote our software like a monolith. You had the app, the web, the database. The database. God, those were the days. You could draw a pretty clean line from the code you were responsible for and the code that you weren't, right? The request entered the service, it executed, and it finished. You could attach a debugger and step through the whole fucking thing if you wanted to. You didn't actually have to understand much about the environment or the stack. You could live in this cozy little IDE world, sometimes venturing out to the debugger world. Code gets deployed, like literally ops problem now. There's the GIF. And in this world, the tools that we had for debugging our systems were really basic, right? There's the metrics and the logs. And when you're talking about metrics, there's two different ways that you can use the term. There's the generic term metric, like telemetry, numbers, like we're all cool with that. And then there's the metric, capital M, which is just a number with some tags appended. And for a long-ass time, that was really the basis of everything we had to understand our systems because resources were so expensive, right? You couldn't be wasteful with your bits and just spew out entire structs into your log, right? No, it's about those tiny little numbers that we just aggregate, the counters and the gauges. And 2003, where am I? I have too many things. And every time something would break, what would you do? Well, it helped that things tend to break over and over and over. So every time something broke, you would write a monitoring check so that you'd find it next time. Write a dashboard. This time we'll find it immediately next time when it happens. You'd add maybe a custom metric if you thought you could afford it, and restart the process. Done. There weren't that many things that could fail. You'd find them all. But as we know, the world hasn't been that simple in quite a while. Everything is getting way more complicated. I'm just not even going to try. But honestly, we've also gotten a lot better as an industry. We've gotten better at computering. It's true. We've gotten better at computering. Things are so much more reliable. Well, the future's here. It's unevenly present. Things have the potential to be so much more reliable and resilient than they did 20 years ago, right? And this is why, there's this growth stage that companies go through where you're trying to have your technology beat out the rate of decay and users banging on shit. It's just are you going to survive or not? It's very exciting. But really, nowadays, if you get to this point and you have a modern system, almost every time you get paged, it should be something new, right? You should not be in the state where you're like, oh, this again. Oh, this again. You can fix it. We should be able to fix these problems. We should, history doesn't repeat, but it rhymes, right? And it may take a while to fix things, but we shouldn't just be, bludgeoning ourselves with these things anymore. Every time you get paged about something, it should be about something fairly new or not understood. Also, speaking of being paged, we don't really have dev and ops anymore. Instead, we have platform engineers. I don't know, too soon? But in the bad old days, all of production tooling, it only spoke ops languages. So you could understand why, if a software engineer wanted to go and understand their software in production, they had to have two jobs. They had to understand two worlds and two languages. there it is. Because all of the stuff there on the right in the ops world was like speaking the language of here are your multiple CPUs, here are the 3 or 4 different kinds of RAM, here are the everything under /proc we're going to graph because it makes us feel good. Not super useful, but and so if you're a software engineer like wandering over to, and you're like, I'm thinking about endpoints and variables and functions, why the fuck are there 4 types of RAM? Like it was not really useful to the average software engineer. Also, I kind of feel like, I got those in the wrong order, how our stuff should be functioning, and this is how our stuff, like how our code really should be functioning and how our systems really should be functioning. It was all very much in theory, and it was all very much from the perspective of the app and the systems. Turns out, I don't actually care about either of those, right? What I actually care about is the user's experience. And we didn't really have anything but the most nascent ways of understanding that 20 years ago. And like this is where observability comes in, right? Like we know by now, I hope, that you can't debug very well without things like high cardinality and high dimensionality, arbitrarily wide structured logs, exploratory, like open-ended investigation, different visualizations, like indexes, schemas, all those things. Anything that is a prediction of what's going to happen or how it will look is something that defeats your observability superpowers. So with all of this mess going on, we also can't just create a new dashboard and call it a day. We can't just come up with a monitoring check for every new failure, because honestly, most of the things you get paged about probably won't even be failures as they used to be understood, right? Something's going above a threshold. Is it good or is it bad? Something is, deteriorating. So, because most of the things you're getting paged about shouldn't be symptoms, and they shouldn't be like when we have customers who use Honeycomb and they're changing over from their monitoring and alerts over to SLOs, you can delete 90% or more of those paging alerts because all they are is noise. They're flapping and they're noisy and they don't actually correlate to users' experience. Does your user know if your disk filled up? I hope not. So why should you have to wake up in the middle of the night? Right? It's all about realigning the incentives of the people who are doing the work and getting paged with the people who are experiencing your website. When they're in pain, you should be in pain, but not unless. I mean, relative. They should align, is all I'm saying. And the old technique of just let's create a dashboard so we can see this immediately really gets to the problem with that whole way of debugging, because I don't think of it as debugging, and I know I'm not trying to be a pedant. This is not something where I'm like, that's the wrong usage of the word. But when you're trying to understand how we understand systems, there's this way where we just slap up a dashboard, and then what do we do with it? We just scan it with our eyes. We're like, well, there's a spike over there. I'm just going to go over here and start paging. Is there a spike that looks like that anywhere over here? That you just start looking through all of your old dashboards. Every single dashboard is an artifact of some past outage, some past failure. How many of them are relevant? And you're not really thinking. You're not creating a richer map in your brain about what's going on, and where are things getting worse, and what have you tried already? And all you're doing is this sort of passive pattern matching. And I think it's really bad for us. And software engineers, I think that are better equipped to make this transition than a lot of ops folks are, because, ops folks, kind of queens of the dashboards, but software engineers at least are used to the mechanisms of forming a hypothesis, testing it, trying something, oh, it didn't work, or it did work, and trying something else based on that. It's like following breadcrumbs, right? And it's I thought of this metaphor earlier. 20 questions, right? The game 20 questions where it's I've got a word or a thing I'm thinking of, you have to guess it. And using dashboards is like using your guesses to go, pizza. I'm like, no, it's not pizza. And you're like, well, it's that dog. I'm like, no, it's not that dog. And they're like, lightning. I'm like, no, it's not that. You're just is it that? Is it that? Is that? That's what dealing with dashboards like this is like. Whereas what you want to be doing is well, is it a person, place, or thing? It's a person. Well, is it someone I know? You know, and narrow it down to it's just right in front of me, right? But like debugging should be more like that, like consistently reducing the search space, closing in on the answer. At Honeycomb, we call it the cognitive loop, where you try something, you look at the output, you learn something from the output, and it informs the next step that you take, right? And there are ways to like automate that and shrink it up so you don't have to do it. But like that fundamental, like so much of what debugging is here's a thing I care about, for whatever reason I care about it. How is it different? And what are all of the ways it is different from everything else that I don't care about, right? And the model, this was a great model for when things were failing, you know, in the same way repeatedly. But when it's a different problem every time, you really need to get, like, honestly, being the person who can intuit the answer feels great. Like, I miss feeling like God. I'd just be like, I know you're all looking at that in the line, but I know it's Redis. I know it doesn't say Redis, but I know it. Aren't I great? Like, it's such a good feeling. Doesn't scale. It's too bad. Maybe not entirely healthy for our egos, whatever. Whose password is God? It's passively consuming data that somebody pulled into a dashboard out of an outage some years ago for some completely different thing. So I think that one of the biggest things that we can do, like to shift from like just a sort of like operation mindset to an understanding of systems mindset, is to stop. I'm not saying get rid of your dashboards, but know their place, right? And by the way, I'm not, all my rants about dashboards, just like my rants about logs, you know, I'm all for logs that are arbitrarily wide structured data, like data blobs, aka canonical logs. But the assumptions that people bring to the table when you say logs are things like strings, just sort of shit out wherever you want to. Like you can't like reconstitute and do it. Like that's not the kind of logs I want. And dashboards that you can drill down into, dashboards where you can go, and what about this? And what about that? And what if I add this? And what if I do that? Great. Those are great, but they are not most of them. Pattern matching is part of debugging, but it is not all of debugging. And, you know, like becoming a powerful engineer, so much of it involves having a good map of your system in your head and knowing how to reason about it. It's just so much. I think a lot of us have some sort of dashboard-induced muscle atrophy to recover from. So like, are you debugging? You know, are you using interactive tools? Are you using tools? One of the things that I think is so powerful about observability that most people don't pay attention to is the fact that if you look at an observability tool like Honeycomb or Lightstep, that is the full list in my opinion. Sorry, had to get that out there. But if you look at an observability tool, it's talking in the language of endpoints, API endpoints, variables, functions. You know, if you're a software engineer who's trying to understand how your code works, it makes sense, right? And we're all software engineers now. Every single person in this room writes code, owns code. Like, there is no more dev versus ops. Like, it's not that DevOps is dead because, you know, nothing never dies. But, like, we're all engineers. We all have to write this shit. We all have to run this shit. The question matters more than the answer, right? Like, fuck. The question matters more than the answer. Often, if you can even get to the point where you can formulate the question, like you're halfway to the answer. Sometimes if you get to the question, you're all the way to the answer, which is why that step of forcing yourself to stop and make a question is so important. Which is why those predefined questions and pre-aggregated things are just like death to your brain. It's hard to craft a query. There's kind of no way around that. And I am really bad at visualizing things graphically. I've never been the person who does this. My friend Ben, I've been working off and on for 20 years. He's the person who builds these beautiful dashboards. I come in the next morning and I bookmark them. It's hard to craft them, but it's easy to tweak them. Anyone can take a really complex query or dashboard and like go, well, but I don't want that. I want this detail, or I want it done there. Right? So like when I talk about this being a social, like this is a team effort in a very real way, like all of us have done this work and we should be trying to share it. I also want to take a little bit of a detour here and just talk about this whole socio-technical systems thing. I was thinking about this the other day. Yes, we've all heard their spiel and everything, but thought experiment. Imagine that you work at the New York Times along with hundreds of other engineers, and one day you wake up and realize you've been Freaky Friday'd with the Washington Post engineers, right? They're in your newsroom or engineer, whatever. You're in theirs, and you're supposed to just start running the systems. Basically, you probably have the same amount of competency and the same kind of knowledge and stuff, right? But how easy would that be? It would not be very easy. So much of the system lives in our heads, right? It literally lives in your head. It literally lives in your team's heads, right? It's so much of our collective knowledge, we try to extract it into tools, and the source of truth should not be your head. The source of truth should be a tool that you all have access to. But so much of the wealth of knowledge that we have doesn't actually exist in documentation, doesn't actually exist in run books. It exists in the people around you, which is why we have to think about things like how quickly do we replace members of this team, or don't let someone be on the same team for 10 years, right? That's not healthy for anyone. Systems need to be resilient to people leaving, just like they need to be resilient to election failures. The system, what was I going to say? I don't remember what I was going to say. Doesn't matter. The system lives in your collective memories too. But debugging is very much a team sport, right? We all draw from our own experiences and memories, various histories, and our teammates. Who among us hasn't seen a terrific graph dropped into Slack, right, and bookmarked it for later? At Facebook, Scuba, which was the great aunt of Honeycomb, was grandmother, not a descendant, an ascendant. Whatever. Everyone I knew at Facebook had a text file somewhere of shortened URLs for Scuba queries with a sentence or two describing this was Thanksgiving of 2021 when this broke or this rolled over or I got this from so and so. All the context about where this thing came from. And so when you wanted to debug something, would you go to the front page and start crafting a query? No, you would not. No, you'd go to your fucking notepad. Sorry. Small conferences mean you don't care about the mouth, right? I just assume. You'd go to your Jesus. You'd go to your notepad and you'd be like, that looks similar. I'm going to click on that and then I'm going to tweak that. And this is a good thing, right? We are stronger together. Not all of us have to be good at visualizations. Tests are for known unknowns, monitoring are for known unknowns. Once you know about something, you can test for it. I feel like testing and monitoring are they're like siblings, right? They're just from different directions. I'm almost done. I don't even know how long this took, but I think I'm about 30 minutes. The last two slides I want to show you first is this. It is so important that we find bugs quickly, because the cost of finding them and fixing them goes up exponentially. You type a bug, you delete it, good job. You have fixed it as fast as it can possibly be fixed, right? You find it when you're running tests, excellent job, right? You let it get shipped out to production. The point in time that has the most possible energy, whatever, to save your ass and that of your customers and everyone around you is that moment in time after you've just shipped your changes to production. You have the data, you know what you're trying to do, you know why you're trying to do it, you know what you tried that didn't work, you know what the instrumentation says, you know all this stuff. And if you get it deployed within 10, 15 minutes, and then you go look at it through your instrumentation, through the lens of this shit that you just wrote, and you're asking yourself, is it doing what I expected it to do? Does anything look weird? Right? It doesn't take a lot of time if you're familiar with your tools. And if you're familiar with your tools from looking at it every day, you can tell in just a glance or two if something looks weird, right? If you're not familiar, it might take 5 minutes. But those 5 minutes will save you so much time and pain. The way that teams get so bogged down and they start going so slowly and everyone's frustrated because you can't, is because a bunch of this shit backs up, right? And everything takes forever. And one of the most powerful things you can do to get this engine running again is start finding the bugs quickly. before your users can even report them, like when they pop into production, and maybe check up on it, right? And a couple times a day for the next week, if it's, or like for a month if it's a scary change, right? You have so much more capacity to find it before anyone else. And like, I just see us wasting that. The other thing is this super depressing slide that I still love, which is like, developers self-report that we spend 42% of our time just wasted on not moving the business forward in any way, shape, or form, but just like trying to figure out how to repro, trying to figure out what we were doing before we got interrupted, trying to do it again because, whatever. Like, there's just some low-hanging fruit here is what I'm saying. And I really feel like if you're like, I want to get better at this, I feel like learning to debug better, learning facility with tools that are modern, that speak the language of your software, that handle high cardinality, high dimensionality, that improve the way you think about your systems. That's a gift to yourself and your team that's just amazing. So that's all.